What's up, everyone? Welcome back. Today's geometry puzzle is a really satisfying one. The trick is to uncover a few hidden triangles, and once you do, the answer falls into place beautifully. Let's look at the diagram. We have a right triangle, ABC, with a right angle at point B. Inside the triangle, there's a segment PQ. Point P lies on the hypotenuse, AC, and point Q lies on the base, BC. We're given three important facts. First, PQ is perpendicular to the hypotenuse, AC. Second, P is the midpoint of the hypotenuse, so AP equals PC. And finally, AB is 8 units, while BQ is 6 units. Our goal is to find the exact area of triangle CQP. Let's begin by drawing one extra line. Join point A to point Q. Now look at triangle ABQ. It's a right triangle with legs 8 and 6. Using the Pythagorean theorem, AQ squared equals 8 squared plus 6 squared. That's 64 plus 36, which is 100. So AQ equals 10. Now look at triangle AQC. Point P is the midpoint of side AC, and PQ is perpendicular to AC. That means PQ is the perpendicular bisector of segment AC. A point on the perpendicular bisector of a segment is always the same distance from both endpoints. Since point Q lies on that perpendicular bisector, we have QA equals QC. But we already found that QA is 10. So, QC is also 10. Now let's return to the large right triangle, ABC. Its height is 8. Its base is made of 2 pieces. BQ is 6, and QC is 10. So, BC equals 16. Apply the Pythagorean theorem one more time. AC squared equals 8 squared plus 16 squared. That's 64 plus 256, which is 320. So AC equals the square root of 320, which simplifies to 8 times the square root of 5. Since P is the midpoint of the hypotenuse, PC is exactly half of AC. So PC equals 4 times the square root of 5. Now focus on our target triangle, triangle CQP. It's a right triangle. Its hypotenuse is QC, which is 10. Its base is PC, which is 4 times the square root of 5. Let's find the remaining side, QP. Using the Pythagorean theorem, the quantity 4 times the square root of 5 squared plus QP squared equals 10 squared. 4 squared is 16. The square root of 5 squared is 5. So the first term becomes 80. That gives 80 plus QP squared equals 100. Subtract 80. QP squared equals 20. Taking the square root, we get QP equals 2 times the square root of 5. Now, for the final step, the area of triangle CQP is 1/2 times base times height. Substitute the values. 1/2 times 4 times the square root of 5 times 2 times the square root of 5. 1/2 times 2 is 1, and the square root of 5 times the square root of 5 is simply 5. So the area becomes 4 times 5, which is 20 square units. And that's our final answer. If you enjoyed this challenge, don't forget to like the video, subscribe for more geometry puzzles, and I'll see you in the next one.